Alright, so good afternoon. We are working on section 7.2, and section 7.2 goes through some formulas and so that it kind of piggybacks a little bit off of 7.1 with exponential equations, but it takes it into more of a real-world format where you can actually see them being applied in a real-world setting. Okay, so this first one that we're going to look at here is population of a certain inner city area is estimated to be declining according to the model P of t equals 574,000 times e taken to the power of negative 0.022 times t, where t is the number of years from the present. What does, that should say what does, not what dies, sorry. What does this model predict the population to be in 4 years? Okay, and round to the nearest person. Alright, so again, we're looking for this for 4 years. Okay, so P of 4 equals 574,000 times e to the power of negative 0.022 times 4. Okay. Alright, so my first suggestion, because all we did was replace t equals 4, okay, because t was representative of time. Okay, so my first suggestion to you would be to go ahead and make sure that you consolidate that exponent there. Okay, so let me get into my calculator here. Alright, so negative 0.022 times 4. Alright, so P of 4 is going to equal 574,000 times e to the negative 0.088 power. Alright, now, the most common mistake here is that students want to do 574,000 times e, okay, but these are actually two different statements. So you actually have to take e to that first, then multiply that answer times 574,000. Okay, so my next step here, which I'm going to highlight in green, is to go ahead and take e to that power. So if you have a TI-84, you would hit second ln, and that'll put the e on the screen, and then all you have to do is type in your exponent. So negative 0.088. Alright, and so that gives us P of 4 equals 574,000 times my answer, which I want to use as many decimal places as possible so that I get the most accurate answer. So 0.9157608,767. Okay, and that's every decimal place that my calculator shows. If your calculator shows more decimal places, feel free to use them. We should get to the same answer. Okay. Alright, my last step is to multiply all of this together. Okay, multiply the whole thing. So we're going to get the population after 4 years is going to show up to be 525,646.7432. Okay. Now notice there at the end of the problem it does say round to the nearest person. Okay, so we have this kind of a partial person here, and no one wants to be a partial person. So the question is, do we go up or do we go down? Okay, and the answer should be up, right? Because that is 5 or more, where that 7 is sitting right there. Okay, that's more than half, so we should go up to the population after 4 years. It's going to be equal to 525,647 people, and that is my answer. Alright, so you may see a population problem. It could be declining, but it also could be growing too. So be aware that of the, certain words in your word problem right here. And this one did happen to say declining, so I expect my population after 4 years to be less than that 574,000. Alright, example number 2. Ariana invest $5,500 in a new savings account here, which earns 5.6% annual interest, compounded. Let me zoom out just a little bit. I'm sorry. Compounded daily. And what will be the value of her investment after 7 years, right? All right, so we are going to need a formula for this. And so you have two formulas that you do have to be made aware of in this chapter. All right, both are not that difficult at all, I promise. Okay. This one happens to be the compound interest formula. So let's write that out real quick. Compound interest formula. Okay. And this one simply states the amount after T number of years equals the principal, or what you put in, like a savings account, for example, times parentheses 1 plus R over N. Okay, that's the interest rate over how many times it's compounded, which is N. And we're going to take that to the N times T power. Okay. All right, so now I'm going to go ahead and write out the rest of this. So P is principal. And here we are talking about money. Okay. So it's the money that you're putting in. R is the interest rate. And we have to make sure that we convert that to a decimal. Okay, so in decimal form. All right. T, of course, is time. And the important thing about time is it must be placed in years. Okay, it must always be in years. So, say for example, this had said 7 months up here instead of 7 years. I'd have to put that as 7 over 12 because it expects it to be in years. Time must be in years. All right, and N is the number of times per year that interest is compounded. Okay. So, for example, if this is a bank, which it is, this says this is a new savings account. Okay, this is the number of times. N is the number of times per year that the interest is compounded. Okay. All right. So let's go back to our problem here. I'm going to scroll that up just a hair. Okay. Let's identify each piece here. Okay. All right. So we have 5,500. That happens to be P. Okay. That's my principal. That's my amount that I'm putting in. 5.6%. That happens to be my R. Where's my T? Right there. 7 years. Alright, so the only thing we're missing here is N. Okay, so when you need to look for N, you need to look for that word compounded. So we see right here, right after interest rate, that's usually where it's at. It's after the interest rate. We see compounded daily, and that's N. Now, compounded daily. Well, we have to remember how many days are in a year. And that would be 365. Very good. Okay? Now be careful about that because that could say compounded monthly. If that was the case, then N would be 12. If it's compounded bi-monthly, N would equal 6. Okay? And so what we could do is list a bunch of examples here. Before we actually get to the problem itself, let's go ahead and go through a bunch of examples, okay? So we already did compounded daily. How about compounded monthly? Well, we said that one out loud, but let's make sure we write it down. That would be N equals 12, right? If it's compounded bi-monthly, then N would equal 6. If it's compounded weekly, then N would equal 52 because there's 52 weeks in a year. Let's see, if it's compounded annually, then n would equal, probably the easiest one, n would equal 1. If it's compounded semi-annually, that would be every 6 months, so n would equal 2. Alright, and then one more. I almost forgot this one. Compounded quarterly. If it's compounded quarterly, n would equal 4. Think of quarters. How many quarters are there in a year? Or, I'm sorry. How many quarters are in a dollar? And that would be 4. Okay. Alright, so I think that about sums it up as far as some values there to kind of help you get through these, because you will need to know those, okay, as far as what your n value would equal. Okay, and once you do these a few times, you'll get these down a piece of cake. Okay. Alright, so now let's go back to the problem itself, okay, about Ariana investing $5,500 in a new savings account which earns 5.6% annual interest, compounded daily. What will be the value of her investment after 7 years? Okay. Alright, so I'm just trying to free up a little bit of room here. There we go. Alright, so we're trying to find the amount after 7 years equals, principal is $5,500 times 1 plus, now I need the rate to be a decimal, so I'm going to move it over twice. So 0.056 over my n, which is 365, close my parentheses, and then we have an exponent out there of n times t. N is 365 times 7. Alright, so I'm going to do this in pieces, and I know a lot of you, if you have like a TI-84 or a TI Nspire, you could do this all at once. But I'm going to break this down and do this in pieces. Okay, so first off, I'm going to do that 365 times 7. So 365 times 7. 2,555. Alright, so the amount after 7 years equals 5,500 times 1 plus 0.056 over 365 taken to the 2,555th power. Alright, my next step here is to go ahead and divide this. 0.056 divided by 300. That's my rate divided by n. So 0.056 divided by 365. Alright, let's see. The amount after 7 years equals 5,500 times 1 plus 0.000. And again, I want to use as many decimal places as possible. 153 424 6575. Taken to the power of 2,555. Okay. Alright, next step. I'm going to add 1 to that really large decimal there. Okay. So the amount after 7 years equals 5,500 times 1.000153 424 6575 to the power of 2,555. Alright, I'm going to go back to yellow now, because I'm going to take this really long decimal, okay, with a 1 attached to it, and take it to the power of 2,555. Okay. Let me correct that just a little bit. It looked like 2,556, and I didn't want anybody to misinterpret that. Okay. Alright, so let's see. Put in that really long decimal here, taken to the power of 2,555. Alright, and so let's see. Go back to my pen here. The amount after 7 years equals 5,500 times 1.479893 213. Okay. And last step here, multiply that answer by 5,500. So we get an answer after 7 years of $8,139.412671. Okay, and so when we're dealing with money, of course, we need to round this to 2 decimal places. All right, so that looks like that's going to stay 41 cents. So after 7 years, it looks like she has $8,139.41, which happens to be her answer. Okay. Now, there could be a part 1 and a part 2 on this type of question. Part 1 could be how much does she have after 7 years. Part 2 could be how much interest did she earn after 7 years. And to find that out, I would need to subtract $8,139.41, subtract from that her investment, okay, or what we called P, right? And once I subtract those, minus 5,500, $2,639.41, okay? Now, not every one of them have a part 1 and a part 2, but this is just in case, okay? I did not put part 2 here on this video, but this is just in case. I mean, sometimes Hawks will ask for it, and sometimes there will be a part 1 and a part 2. Sometimes there will only be a part 1, okay? So you just need to be aware and make sure that you pay attention to what it's asking, okay? So if there was a part 2 and it asked how much interest was earned on the account, this is the amount you'd put in, $2,639.41, okay? All right. Next question. Eva Invest. Let me slide this down just a little bit. Give me just a minute. I just want to slide this down a little bit. So that way it's not in our way. Well, it's just not going to let me, is it? Which is fine. Or maybe I moved it too far down. Maybe I moved it too far down. That's very possible. Could have moved it too far down that, yeah. That's exactly what happened. Okay. All right. Well, hopefully you skipped past that little bit of trying to adjust things and move things around. Okay. I do have a problem that's way down here at the bottom, and I will try to move that back up before, or after I finish the video, I'll try to move it back up so that way you're not having to scroll so far down just to see that problem. Okay. All right. So on this particular problem, we have Eva this time. Okay, Eva invests $7,900 in a new savings account, which earns 4.9% annual interest, compounded continuously this time. So what will be the value of her investment after 3 years? Okay, now this is a different formula this time, and I only want you to use this formula when you see that it says compounded continuously. Okay, because the name of this formula is the continuous compounding formula. Okay, and it simply says A of t equals P times E taken to the power of R times T. Okay, so it's a little simpler formula here. Okay, so we can go back through and highlight how much did she put in. That's 7,900, so that's P right there. Okay, in a new savings account which earns 4.9% annual interest. Okay, so how much is her rate? That'd be 4.9. Okay, and then we didn't identify the time, which was 3 years. There we go. Okay, and then of course that word continuously right there, which means I have to use this formula right here. Okay, now if it says it's compounded any other way besides continuously, that would be monthly, annually, quarterly, bi-monthly, daily, then you must use the formula that we previously used, okay? But you only use this one if you see that word continuously, okay? The problem will specifically say continuously, and when you see continuously, this is the formula you should use. All right, so let's plug in our amounts here. So the amount after 3 years equals 7,900 times E to the R. Again, we need to change that to a decimal, so 0.049 times 3 years. All right, so again, a lot of you could probably punch this into your calculator all at one thing, okay, all at one time. But again, I'm going to go ahead and take it in parts here, okay? All right, so the first thing I'm going to go ahead and take care of is that 0.049 times 3. So 0.049 times 3. 0.147. E to the oh no, there's no O in there, 0.147. There you go. All right, next part. I'm going to take E to that power. So A, the amount after 3 years, equals 7,900. Second, ln, 0.147. Okay, and again, you want to use as many decimal places as possible. So 1.158. 353,963. All right, one more step here. This one's a little bit shorter. Okay, 7,900 times all of that. Times 7,900. So she has in her account $9,150 and 996,308. All right, now what do we do in this case right here? We want to round it to the nearest penny. That 6 tells me to go up, but the number to the left there is a 9, so it must go up as well, which is going to make the 9 next to it go up. So, how much does she have in her account? $9,151 even. There we go, and that is her answer after 3 years. All right, keep in mind what we did earlier, okay? If there happens to be a part 2 on this question, the part 2 will say how much interest has she earned on this account. In that case, you would do minus 7,900, okay, which is that principal, okay, the amount that she put in starting off. So minus 7,900 gives us $1,251. Interest earned. All right. Just please be careful about these money questions. Maybe the hardest part is probably deciding which formula to use, but if you'll pay attention to that word continuously, The only time you'll use the continuous compounding formula is when it says compounded continuously. That's the only time. Okay? Now, you will probably see at least one question in Hawks where a person is deciding between two accounts, like account 1 and account 2. So you'll have to calculate twice the principal amount in both accounts. And of course, the one that earns more is the account that you want to choose. Okay, so again, you're just going to have to calculate it twice. Okay, now I saved the hardest question last. See if I can drag this up just a little bit. So it's not so far down. The reason I'm doing it now is because if I write on the screen, it's not going to move up my text. You would still have to drag way, 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 way down just to see anything. So I'm just trying to save you time. My goodness, it's pretty far down there, isn't it? Okay, well, tell you what, we'll just leave it down there, okay? Just don't forget on your class notes to make sure you scroll down pretty far, okay? All right, now, this really pertains also to the signature assignment, okay? So your signature assignment is very similar here, okay? So we see the half-life of nitrogen-13 is approximately 9.97 minutes, okay? So on A, we have to determine A, so that A of T equals A of O times A of T, okay? So we're actually trying to find, the value here. We're trying to find the value here of A, right there, okay? Describes the amount of nitrogen-13 left at T minutes, where A of O is the amount of time at T equals 0, okay? Round to 6 decimal places. All right, now, we don't know what A of T is, and we don't know what A of O is, okay? But A of O is my starting amount, okay? A of O is my starting amount. And A of T, okay, regardless of what T is, I mean, we know the half-life up there is going to be 9.97 minutes. But A of T is going to be half that starting amount. Half of starting amount. Okay, so for example, if you pick 100 for A of O, okay, then you need to pick 50 for A of T. Okay, so you know what I'm saying is that you get to pick the values here, okay, because we're solving for A. We're trying to find what the value of A is. All right. So let's go ahead and use those values right there, 100, and then A of T is going to be 50. All right, because I think those are good amounts. So we have 50 equals 100 times A. Now that T right there is what's listed right up here, okay, 9.97 minutes. So 9.97 minutes. There we go. All right, so what I want to do is, and I know this is kind of getting ahead of ourselves because really logarithms don't start until 7.3 and 7.4. However, this problem is in 7.2, okay? So it's kind of out of place. I think the problem should be in 7.3 and 7.4. Unfortunately, it's in 7.2, so we've got to deal with it, and we'll get through it, don't worry, okay? All right, so what I want you to do is I want you to go ahead and take the log of both sides. The log of 50 equals log of hang on. I missed a step. I apologize so much. Okay, let's go back to this right here. So we plugged in 50 equals 100 times a to the 9.97 power. Okay, what I need to do first is that I need to go ahead and get that 100 off of there. Okay, so I'm going to divide by 100. All right, so this is getting rid of that. All right, 50 divided by 100, I believe that's 0.5. Okay, punch in your calculator, I believe it's 0.5. So 0.5 equals a to the power of 9.97. Okay, now we can't just simply use exponential rules here because we have an exponent that happens to be a variable. Okay, our variable doesn't happen to be in the exponent like we did back in 7.1, happens to be my base. Okay, so this is when we're going to have to take the log of both sides. So log of 0.5 equals log of a to the power of 9.97. All right, I'm going to slide this over just a little bit because I'm going to need a little bit more room. Okay. All right, now in our calculator we can go ahead and punch in log of 5. Okay, so log of not just 5 but 0.5. So log of 0.5 gives me negative 0.301029997. Okay, again, I'm writing every decimal place that I have there. Okay, which equals log of a to the power of 9.97. All right, so what I did was I went ahead, I just punched this into the calculator, okay, to get that. Okay, so log of 5 came out to that negative number. Okay, you're going to find out when we get into logarithms, if you take a logarithm of anything between 0 and 1, it's going to come out negative. Okay, but anything greater than 1 will always come out positive. Okay, all right, so what we need to do now is our next step is to move our exponent here to the front. Okay, and this is one of our logarithmic properties. Okay, so this is one of our log properties. Now, you really won't see log properties until 7.4. There's 3 log properties, and I don't want to get into all 3 of them quite yet, but one of your log properties is if you're taking the log of a number and it has a power, okay, you can move that power to the front of the log. All right, so this is what it's going to look like once it's rewritten. Negative 0.301029997 equals 9.97 times log a. Okay, because that's all that's left over there is log a. All right, now we can divide both sides by 9.97. Okay, this is going to get rid of this, which is just going to leave log a equals, let me punch that in. So let's see, that big long decimal divided by 9.97 is, oh, it didn't change much, did it? Negative, maybe a little bit, 0.031935803. All right, now when we get into 7.3 and 7.4, you're going to learn about common log and natural log. Okay, so this is common log. And it has a base of 10. Okay, so we have to rewrite this. Okay, the base is right here. Okay, so we have to rewrite this as 10 to the negative 0.030193580 3, and that's going to equal A. Okay, so we're almost finished. Okay, what we're doing here is we're converting from logarithmic form back to exponential. Okay, so we are converting. So again, converting from exponential, our base is right here, 10 to this power equals A. Okay, the only thing that's going to be left over here is that letter, A itself. Okay, all right, so 10 taken to that power gives me a value of 0.9328384 equals A. And that might be more decimal places than what it's asking for. It said up here in the problem, it said round to 6 decimal places. 1, 2, 3, 4, 5, 6. This is the 6th decimal place. That 4 doesn't mean anything, does it? So 0.9328338 equals A. And that is the answer to part 1. Whew, that's a lot, isn't it? It sure is. It is a lot to have to solve just that one part, okay? And so I want you to be extremely patient, and if you need to send me a question, an IDKA question regarding this, and I need to work out a different one, please feel free to, okay? Every one of these is going to have the same exact formula, okay? The only thing that's going to change is your T. T in this case was 9.97, but your T could equal like 5.19 or, really any value, okay? So that doesn't mean that everybody's A value is going to be the same, okay? Because since your T value changes, it's going to change that A value, okay? Now, we did have a step 2 and a step 3. All right, so let's scroll over here. Step 2 is B, okay? So how much of a 3 gram sample of nitrogen-13 would remain after 8 minutes, okay? All right, so we are using this formula. Let's list it up here. So we're trying to find the amount after 8 minutes equals A of 0 is my starting amount, so it'd be 3 times A, which we just found, 0.9328838 taken to the T power, which happens to be 8 in this case. All right, so we have to do that 0.932838 taken to the 8th power. Okay, let me write that step out. A after 8 minutes, the amount after 8 minutes equals 3 times 0.57338962886. Okay. Again, all I did was I did that 0.932838 to the 8th power. All right, my next step is to multiply that times 3. And that's going to give me my answer, the amount after 8 minutes. Okay, it's going to be 3 times that. That times 3, 1.72. It says we can round to how many decimal places? I believe 3. 1.720. And there is my answer. All right. So step 1 is the hardest part. A is the hardest part. But once you find A, it's pretty easy. Okay? Because step 2, which is B, all you're doing is plugging in the sample amount and how many minutes has gone by. Okay? Same thing with C. You're going to be doing the same exact thing. This time it happens to be after 5 minutes. So the amount after 5 minutes equals, it's still a 3 gram sample. Let me say that correctly. 3 gram sample. 3 times 0.9328838 taken to the 5th power. All right, so one more time. We're going to take that to the 5th power. So let's see. 0.93288 taken to the 5th power. Okay. The amount after 5 years equals 3 times 0.706368 2102. And one more time in green here. The amount after 5 years, we got to do 3 times that number. So that number times 3 gives me, and again we can round to how many decimal places? 3 it looks like. 2.119, which is my answer for part 3. Alright, so again the tricky part is part number 1, okay? Which this was A down here. Okay? I know I kind of extended it because I wanted to show step by step by step how to work through that problem, okay? Just make sure you're careful with the formula itself. A of 0 is the starting amount. A of t happens to be half of the starting amount, okay? So again, you know, when you're doing step 1, you get to plug in the values there. So if you want to do 10 and 5, go right ahead. If you want to do smaller numbers than what I chose, that is fine. Just make sure A of t has to be half of whatever you pick for A of 0. Alright, I hope this helps for 7.2. 7.2 is a little bit more complicated than what it used to be in the past. But again, if you have any questions, please, continue to take those screenshots. Send them to me through email with IDK. That's all you have to put. And we'll shoot a video. Appreciate it.